Here's a trick to sum the series n equals 1 up to infinity, 1 divided by n times n plus 1. We write 1 over n times n plus 1 as 1 over n minus 1 over n plus 1. Then the partial sums of this series, the sum from n equals 1 up to m, would be the sum from n equals 1 up to m of 1 over n minus 1 over n plus 1. Now this is what's known as a telescoping series, because if we write out the terms, we get 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4 and so on, all the way up to minus 1 over m plus 1 over m minus 1 over m plus 1. And the whole thing collapses like a telescope because all of these terms just add to 0. And we're left with just 1 minus 1 over n plus 1. And by definition, this infinite sum is equal to the limit of the partial sums, which is the limit as m approaches infinity of 1 minus 1 over n plus 1, which is 1. So the answer to our original question is just 1. Now this is actually quite a contrived example in some ways, because if we change the series a little bit and we take the sum from n equals 1 to infinity of 1 over n squared instead, it turns out this series is much more difficult to sum, even though it looks much the same superficially. In fact, being able to write down precisely what the sum of an infinite series is quite rare. It's the exception rather than the rule.